Alright, this is my third good try to make this video, so hopefully it works out this time. We're going to talk about polynomial functions, and this seems like a lot of stuff. But if you want to copy these down, there's a lot of definitions in here, and I'll make sure we kind of hit all of them as we go. And if you have questions about any of them, please ask me. When you see me in class, send an email or tweet at me, or even Mr. Feig or Ms. Delmont, they can help too. If I'm ever out, the other pre-calc teachers around are very. Okay, so first thing we're going to talk about are roots and zeros, and we've already talked about this. In fact, it was on your test and quiz. This is where a graph crosses the x-axis. And if I had to draw a picture of this, I would say, for example, that the roots or the zeros are right here. Okay? I'm currently sitting in the hallway outside the locker room, so if you hear stuff in the background, it's your students, your classmates, is what I'm trying to say. So when you're solving for this, remember you hit 0, you plug in 0, set it equal to 0. Can't talk, right? And solve, it's supposed to be equal, and solve for x. Okay, so that's how you find a 0. Degree is the largest exponent. So if I give you a polynomial, like this, the degree of this one is 8 because that's the largest exponent. The leading coefficient is the number that is in front of, start over there, the number in front of the variable, like x, variable, with the largest degree. So if I was going to point it out here, it would be the number 1 that's right there. Okay, so these are just definitions you should have in your notes, something similar to them. You could Google them and probably come up with a better definition. So here's an example. Give the degree and leading coefficient. Your homework will ask for this. The degree on this one is 4, and the leading coefficient is 3. Okay, so 4 is the degree, it's the biggest, and then this number 3 is in front of it. So is -2 a 0? To find out, you're going to plug in, and you're going to plug in -2 for x and see if it equals f of -2 equals 0. So I'm going to plug it in and show you. 3 times -2 to the 4th minus 3. Sorry, that's wrong. It should just be -2 to the 3rd. Notice I'm putting parentheses around here because I first have to take -2 and cube it and square it and all that stuff. So -2 times -2 is +4, and 4 times 4 is 16. So this should be 3 times 16 minus 2 to the 3rd, -2 to the 3rd is a -8. Okay, this will be +4 minus 2 minus 1. And I'm already kind of looking at this and thinking to myself, 3 times 16, I don't know what that is off the top of my head, but I'm going to have +8 plus 4 minus 2 minus 1. When I add all my, this together makes this. I don't think it's going to be 0. It does not equal 0. So is -2 is 0? No, you could do it in your calculator because, and if you were writing this, you would say because when I plug it in, it doesn't equal 0. Okay, oopsies. The fundamental theorem of algebra, and again, you could probably Google it and come up with a really great definition, but here's what it means to me. Each polynomial of degree 1 or bigger, which is like x squared, x to the 100th, has as many roots as its degree. And they can be real or imaginary. Okay, so now I get to draw on my piece of paper here. So I'm gonna draw some axes here. Give myself a few of them. You should draw these too. So this one, for example, is the graph of y equals x. Okay, it could be 2x plus 3, it could be 4x, but y equals x. Notice it crosses 1 time. Okay, the degree on this is 1. Okay, this is the, oops, skipped a little, but this is the graph. That looks really bad, of a y equals x squared function. Hopefully you remember we call this a parabola. We can also call it a quadratic. And this crosses 2 times. Okay, the degree is 2, crosses 2 times. Next one is third degree. Okay, this is an x cubed. We call it a cubic function. Look at it crosses 3 times. No surprise, 4 times. And I didn't do a good job. I should undo that. I wonder if it'll erase my axis. Yep. I should have made it cross better. I'll redo it for you. Not much better, but I did it. This one crosses 4 times. Okay, this one we call a quartic, kind of like a quarter. This is an x to the 4th, and it crosses 4 times. So what you need to know is that these can cross. They can cross as many times as their degree. We need to talk about the difference between odd and even. Okay, when I have an odd function, notice that I can make x cubed touch 1 time. Okay, this one has 1 real root right here. But since it's an x cubed function, it has 2 imaginary roots. Okay, if I have an x to the 5th, I can still get 1 root. For an odd function, I can never get no real roots. For an even function, though, check this out. I can make an x to the 4th. That's what I'll do for you. I can make it cross 4 times. Okay. I can make it cross 3 times. Okay, so like that was supposed to be 1, 2, 3. I can make it cross 2 times. I'm going to get my W to kind of touch right on there. Or I can make it cross 1 time. Okay, just going to go like that. Oopsies. But the real winner is this one. I can make it cross no times. Okay, so odds have to have at least 1. Evens can have none that are real. They can cross no times and can have up to the number that they have, their degree. Kind of the real last thing about even and odd. Even, either they both go up or they both go down. If they have a negative leading coefficient, they point down. If they have a positive leading coefficient, they go up. When we're talking about an odd function, a positive, and I remember this because I'm right-handed, goes up on the right and down on the left, and that's for positive. If it has a negative leading coefficient, it starts up on the left and down on the right. So this is for your negative. Okay, I've had here before that it's complex numbers, but what I really want to remind you of is imaginary numbers, and that's the number I, which is the square root of -1. And so you need to remember that I squared equals -1. Okay, so this is kind of like the big deal right here. I squared equals -1. We're talking polynomial function. That means, and you can look up the definition in your book, and it's kind of scary, but it means that these here have to be positive integers. Okay, like the degree. Like this, x to the -1, not a polynomial, because it's a negative number. So if you have something that's like x to the 100 plus 4x to the third plus x minus 7, that is a polynomial because it has positive real integer exponents. So positive real integer exponents are the key. Okay, remember, if it has a negative exponent, it is not a polynomial. Okay, so I keep doing that. I'm getting to, I know these are super long notes and there's been a lot of definitions. This is supposed to say polynomial, there's a typo. So the roots are at 2 and -8. So if I drew a picture of this, like here's 2, here's -8, for example, and I'm going to draw, this is going to be of degree 2. It has 2 real roots, and I know that because both of these numbers are real numbers. If these are the zeros, if 2 and -8 are zeros or roots, then x minus 2 and x plus 8, being 8, are factors. So what you need to do now is FOIL them, and I'm going to just do it in my head, but you don't do that, okay? You actually show your work, since I'll probably make a mistake and then somebody will tell me about it. This is the polynomial that represents possibly this picture, okay? Not for sure, it's just a quick sketch, but also it has roots at 2 and -8. And if you solved this and plugged in, for example, +2, plug in +2. How do we know it's a 0? Plug in, is 2 a 0? Well, plug it in. 2 squared plus 6 times 2 minus 16. 4 plus 12 minus 16 equals 0. It does. 2 is a root. If at this point you are overwhelmed, you should save this example for the next day. Okay, so again, polynomials spelled wrong, of course. So here are my roots, which means my factors are x minus 2, x minus 4i, and x plus 4i. Okay, this one is a degree 3. How do I know? Because I have 3 roots. 1, 2, 3. It has 1 real. I know that because 2 is a real number, and 2 imaginary, because 4i and -4i are imaginary numbers. Okay, when you're doing this type, you have to FOIL these first. Okay, FOIL first. So carefully now, x times x, x squared. Right here we get plus 4xi. And right here I get minus 4xi. Hopefully you're noticing that these are going to fall away. And then -4 squared I squared. Okay, so 4 times 4 is 4 squared. I times I is I squared. So I'm going to, these cross out. Okay, these go away, so that's nice. So now I've got x squared minus 4 squared is 16. And I squared, if we flip back on one of those slides, was -1. This is key right here. I squared equals -1. Okay, never forget that. Negative times a negative is a positive. That shouldn't be a 4, that should be a 16. So -1 times -16 is positive 16. Now I've run out of room, but now you're going to FOIL through this last bit here. Okay, so let's see, where could I write it? You can get x cubed minus 2x squared plus 16x minus 32 should be your final answer. Okay, so again, third degree polynomial. It has one real root and two imaginary roots. Okay, so that was a ton of information. I changed the words on these and then they didn't get changed. So this is Wednesday in class. This is Thursday in class. I will be back Thursday to answer your questions and to check that you've been taking notes. So Wednesday in class, do this, be nice to the sub like I'm sure you will be. And then Thursday in class, you're going to do this one here. I know this was super long. I'm sorry. Thanks for watching, guys.